Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about vector space and subspace. This is very easy concept to understand if you have the basics which we already discussed in our previous class. In our last class, we discussed about the concept of spanning a given set of vectors. So this is a continuation class, hoping that you already have that basic knowledge. Based on that, our explanation is provided. So coming to today's class, a vector space. What we call it as a vector space? Suppose if you take a vector 2, 3, 4, this is a vector in a three-dimensional space. See, spanning a vector means by using this vector, what is the space that we are able to span? That we call it as spanning a given set of vectors. Means by taking this vector 2, 3, 4, multiply this vector with 2. Means by using a scalar. So this is how 2, 3, 4 vector looks like in a three-dimensional space. So when you multiply this vector with 2, 4, 6, 8 is the vector which we got. So that vector will be somewhere around here and it is having the same direction. This intuition we already provided in our last class. Means by taking this vector, we are able to move to the next point 4, 6, 8 somewhere around here. Means we can generate a new vector 4, 6, 8 somewhere around here. If you multiply this vector with a negative number, you are able to generate a point that is somewhere around here. If you multiply with -2, you are going to get a value of -2, -3, -4, somewhere around here it will come. Means what's the space that you are able to span by using this vector? This entire line. See, if you take this, the line that passing through the origin, and this is the line which you can move on to any point on this line by using this vector. This is what we call it as vector space. But it has to satisfy some properties. If you want to call it as a vector space, it has to satisfy some properties. What's that properties? Let's try to understand. Closure under scalar multiplication. Closure means you take this vector, you do scalar multiplication. Whatever the new vector which we got, that should be in the same line, same space. That is what closure means. Closure under scalar multiplication. 2 multiplied by 2, 3, 4. You got a vector 4, 6, 8 which is on the same line. Means which is on the same space. Similarly, it has to satisfy the next property, closure under addition. Means you take any two vectors on this line. If you add them, you have to get a new vector that should be on the same line. Means it is covering the same space. Yes, you take 2, 3, 4 plus 4, 6, 8. These two vectors, if you add them 6, 9, 12, you are going to get the vector on the same line. So closure under scalar multiplication, closure under addition, vector addition. The third property it has to satisfy, it should have an identity element. Identity element means here identity element based on addition. 0, 0, 0 is the identity element. What's that mean of identity element means? 2, 3, 4, when it is added with 0, 0, 0, you are going to get the same element 2, 3, 4. Vector added with 0, 0, 0, you are going to get the same vector. Then 0, 0, 0 is called identity element. You take any vector, add with 0, 0, 0, you are going to get the same vector. Similarly, it has to satisfy one more property, the fourth property, additive inverse. Means if you have a vector 2, 3, 4, it should compulsory have an additive inverse. Means 2, 3, 4 added with the -2, 3, 4, you are going to get the identity element. What is meant by identity element? 0, 0, 0 is the identity element here. You take any vector on this vector space. you are going to have a negative side on this negative vector. When you add it with negative of that same vector, you are going to get 0, 0, 0. If these properties are satisfied, then this space we call it as vector space. Similarly, if you take a set of vectors, in our set of vectors we are having two vectors, 2, 3, 4, minus 1, 2, 5. These two vectors are in two different directions. Using these two vectors, we are able to cover the space. It's a plane. Why it is going to cover a space that provided why it is covering a plane space? Plane means this is the example which we have shown. This is a plane in a three-dimensional space. By using these two vectors, 2, 3, 4, minus 1, 2, 5, this is the plane we got. You take any two vectors on this. After adding them, you are going to get a vector on this plane. Closure under addition. Why we are getting that? The graphical intuition which we already provided in our last class. Similarly, with these two vectors, we are getting a plane like this. If you change the vectors, you are going to get a new plane. It should be like this. This is another plane like this. This is the only line? No. If you change the vector, you will get a new line like this. That is also vector space for that vector. Similarly, what's the vector space for these two vectors? This is the plane which we got in three-dimensional space. You multiply with any scalar and add any two vectors on this. You are going to get a vector on this space. Similarly, our vector space is passing through origin because it is an identity element is there. Identity element is there. 0, 0, 0 is the identity element. Now coming to the next one. If you take three vectors, 2, 3, 4, minus 1, 2, 5, 2, 4, minus 6, these three vectors are moving in three different directions. With these three different vectors, we are able to span, means we are able to point any point in the entire three-dimensional space. So what's the vector space belongs to these vectors? The complete three-dimensional space means you using these three vectors by doing scalar multiplication and addition, you can move on to any point on the three-dimensional space. You can move to any point. The graphical intuition, how we can move on to any point, this graphical intuition we provided in our last class. So you take any three vectors in the three-dimensional space. If you add them up, you are going to get a vector in the three-dimensional space. It is satisfying closure property, addition. Similarly, scalar multiplication also satisfies identity element 0, 0, 0 will be there. And additive inverse, you take any vector and inverse it, you are going to get the identity element. So this is what vector space means. Now we need to understand what is subspace. Assume that this is the example. So if you take these three vectors, what is the vector space for these three vectors? It is going to cover the entire three-dimensional space. In this three-dimensional space, if you take any subset of a space, means you take a line using this vector 2, 3, 4, we are able to cover this line, which is satisfying the properties of vector space. Means you multiply this with any scalar, you are going to get a vector on the same line. You take any two vectors on this line, if you add them up, you are going to get a vector on the same line. And we are having identity element, it is passing through origin. We are having inverse element for all the vectors. So that's why this is a subspace for this vector space. And one more important point, how many subspaces will be there? Infinite number of subspaces will be there. You take this vector, you are going to get a subspace like this line. So minus 1, 2, 3, this is the line. Using this vector, you are able to span this entire line, means you are able to get any point on this line by doing scalar multiplication and adding any two vectors. You can move on to any point on this line. Similarly, how many lines you are able to form? So many lines we are able to form. So many subspaces are there, but each subspace has to satisfy these properties. Is this only subspace? No. You consider this plane. This is also a subspace in three-dimensional space. For these vectors, this is a subspace. This plane is a subspace. It is satisfying the properties of vector space. Is this the only plane we have in this three-dimensional space? No. This plane we obtained by using these two vectors, 2, 3, 4 and minus 1, 2, 5. You take any other two vectors, your plane changes. It will move like this, like this, like this. So how many different subspaces available in this three-dimensional vector space? There are so many vector subspaces that are available in our three-dimensional vector space. So all these we call it as subspaces. Not only that, our vector space itself we call it as a subspace because it is satisfying the properties of this. It is very much similar to subset concept. The set itself we call it as a subset. You remove any element from that, still we call it as a subset. You remove two elements, still we call it as a subset. The set itself we call it as a subset. Similarly, the vector space itself we call it as a subspace, and other than that we are having so many subspaces. These are one subspace, this is one plane is a one subspace. Hope you understand the concept of what is meant by vector space and subspace. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.